Unit 9, Day 8, using functions involving e, natural base e. So first off, we're going to define what natural base e is equal to, which you can find easily in your calculator by going in to e to the x. Let's take a look at e to the first power. 2.71828, yada, yada, yada. So it's about 2.718. Now it's there. It's also got its own button. It's so important, it's kind of like pi in that regard. So if we look over here above our division symbol, we can also just do second division symbol and get it that way. Either way works. So, first off, rules of exponents we're going to apply, simplifying the natural base expressions. So e to the 6th times e to the 3rd. E is our base. When we multiply like terms with exponents, we add the exponents. So e to the 6th times e to the 3rd is e to the 9th. Number 2, we're going to simplify. When we divide like terms with exponents, we subtract the exponents. But first we'll simplify. 18 divided by 2 is 9. E to the 6th divided by e to the 4th is e to the 6th minus 4, e squared. 4e to the 3x, quantity squared. So we're going to square 4, and we're going to square e to the 3x. 4 squared is 16. When we raise a power to a power, we multiply the powers. So this becomes 16 times e to the 6x, 2 times 3x. E to the 5th times e to the negative 9th. Again, we add our exponents together. That gives us e to the negative 4th. But we cannot leave a negative exponent. So when we have a negative exponent, what we do is we say that's 1 over e to the positive of that exponent, 1 over e to the 4th. Hopefully this is review for you. We're just looking at using base e. So here, 4e to the 3rd, quantity squared, would give us 16, 4 squared, times e to the 6th, power to a power, divided by 8e to the 5th. So we'll do our division, 2e. Number 6, e divided by e to the x. Well, let's see, that's really e to the 1 divided by e to the x. Like terms with exponents being divided, we subtract the bottom exponent from the top, so we get e to the 1 minus x. And that's as far as we can go with that. Use a calculator to evaluate expression. E to the negative 2. We'll go into our calculator. We'll use the e to the x button right above ln. E to the x, negative 2. 0.135, approximately. 13e to the 0.3. In our calculator, 13 times e to the 0.3. 17.548. E to the negative 0.65 plus 5. E raised to the negative 0.65. And then to that we will add 5. 5.522 approximately. Parent function for natural base e is y equals e to the x. So if we go to plot this, we'll start with power negative 2, negative 1, 0, 1, 2, 3. Now I've plugged all these into my calculator already, so I'll just go ahead and write down my output. 0.135, 0.368. Anything raised to the 0 power is 1, except for 0, but e is not 0. Raised to the first power, about 2.718. Square that, 7.39. 2.718 raised to the third power, 20.09. So at negative 2, we're very small. At negative 1, we're still kind of small. At 0, we get an output of 1. At 1, we get 2.7-ish. At 2, we're almost off the chart already. We are a little bit off the chart already. And then at 3, it goes screaming off into the upper levels. So we know this is our graph. Horizontal asymptote. We can see that we approach 0. Why? Well, e to the negative x is 1 over e to the x. As e to the x gets very large, positive number greater than 1 raised to a very high number becomes a very large number. 1 divided by a very large number becomes very, very small, and it approaches 0. My domain. No restrictions on x. All real numbers. My range, well, I'm always going to be greater than 0 with that horizontal asymptote. So my range will be all real numbers such that y is greater than 0. And my end behavior. To the left, as x approaches negative infinity. Y approaches 0. Never gets there, though. As x approaches positive infinity on the right, y also approaches positive infinity. Y equals 1/2 e to the x. Well, we'll take that entire table we just did and divide everything in half. So at 0, we would have 1/2. At 1, we'd have 1.35. At 2, we'd have 3.7. On the negative side, again, it's just going to approach 0 even quicker. My domain, however, won't change. My range also won't change. Number 10, 3e to the negative 0.7x. So I'm raising now to a negative exponent. So if x is negative, my power becomes positive. So you can think about it reflecting it across the y-axis. What else is happening? The rate is being slowed a little bit because it's not a full 1x, it's minus 0.7x. And then we're going to multiply each output value times 3. So I'll go ahead and do a quick t-chart. When x is negative 2, I got 12.2. When x is negative 1, I got 6-ish. When it was 0, I get 3. Wait, when it's 0, negative 0.7 times 0 is still 0. E to the 0 is still 1. 3 times that is 3. That one makes sense. When I put in 1, I get 1.5. When I put in 2, I get 0.7. So if you want to do these fairly quickly on your calculator, of course you can put that in as your function. We will put in 3 second e to the x negative 0.7x. Enter. And then I'll take a look at my table. (12.2), 6.0, 3, 1.5, 0.7, etc. So that's where I'm getting those values from when I do this. Oh, and also if I wanted to take a look, I can graph this thing. I'm going to take a quick look at my window function. That's fine. We'll go ahead and graph it. That's what it should look like when I graph it. My domain, can x be restricted? No, x is still fine. My range, y is still greater than 0. Next, e to the x minus 3 plus 2. Well, let's see. This is going to make it so that x has to equal 3 for my exponent to be 0. E to the 0 is 1. 1 plus 2 is 3. So when x equals 3, y equals 3. The rest, let me go ahead and write out my table. I've already done this before I started the video. When x is negative 2, y is 2.01. When x is negative 1, 2.02. When x is 0, 2.05. When x is 1, 2.13. When x is 2, 2.37. When x is 3, as we just said, 3. When x is 4, it looks like I have 4.7. So what's really happening? We have now shifted our function right 3 and up 2. Our domain is still all real numbers. No restriction to that. But our range now we've lifted 2 higher. So y, all real numbers such that y is greater than 2. F of x equals e to the negative 0.35 times x plus 1. Quantity minus 2. So again, I've created a t-chart, x, f of x or y, whichever you like. When x is negative 2, f of x is negative 0.58. Negative 1, negative 1. Where'd that come from? Negative 1 plus 1 is 0. 0 times negative 0.35 is still 0. E to the 0, any number raised to the 0 power is 1. 1 minus 2 is minus 1. When x is 0, I get negative 1.3. When x is 1, I get negative 1.5. When x is a bigger number, like 4, negative 1.86. I should have gone higher with my negative numbers, because now I'm multiplying by a negative number. But what we'll see is our graph is now flipped, and it has gone down 2. So negative 1, negative 1, negative 2, negative 0.58. So it goes up a little bit. And what you'll really see is we go up. And then, that's not even exactly right. It's more like this. And then on the bottom side, we know we have an asymptote at negative 2. So our domain, all real numbers once again, and our range, y greater than negative 2. All real numbers such that y is greater than negative 2. Now a little bit of vocabulary. Compound continuous interest. So this is where E really comes into play. Instead of having, I won't go into the details of it. I'll just give you the equation to start off. A equals P, your principal, times e to the RT. R is your rate, your interest rate, annual. T is time in years. P is your principal, your initial amount of money that is being compounded upon. So let's go through some examples. You deposit $3,500 into an account that pays 4% annual interest compounded continuously. What is the balance after 1 year? Well, our A would equal P, 3,500, times e to the R times t, 1 year. We'll plug that in the calculator. $3,500 times e to the 0.04. If I wanted, I could say times 1. $3,642.84. You deposit $4,800 in an account that pays 6.5% annual interest compounded continuously. That's the word you're looking for to be able to use this function with e. What is the balance after 3 years? So now we're going to put in our principal, $4,800, times e to the 0.065, 6.5%, times 3. So again, in the calculator, 4,800 times e to the 0.065 times 3. $5,833.49. And that is it for day 8.